on the second slide, we can see the two TNAs we performed last year. The first 3D TV experiment from Durham, and the second one, the human-robot interaction, together with PSNC, Visionair, and SurfNet. I will first highlight the 3D TV experiment. So on sheet 3, we can see that the experiment took place between 15th and 19th of July. TNA conducted by Durham University, and they asked us to provide an environment in which they could test a new type of 3D visualization. The goal of their TNA was to evaluate the impact of high quality 3D content on audiences, and they made some kind of a new way of generating 3D images based on better viewing experience and making it more natural to look at. And was mainly due to see how people will respond to the new type of 3D, which is better adjusted to what our eyes could see instead of what a computer could generate as a 3D instrument. And the question was, is the perception of the audience in a country outside the UK the same as in the UK? Because they already performed the test inside the UK, and now there was the question, how will, in this case, Dutch people respond to the same type of information? The approach was that 3D TV is already available for, well, quite some years, but it's still not really accepted by the community. People don't really like watching 3D images on 3D televisions. There's no added value, and it's not really a good representation of the real world. It's a real, well, not a fake image, but it seems fake. So they had the new algorithm to make those films, and they asked us, could you provide an environment which we can control, so we know for sure that every test is the same? And can you also give us some people, so students or employees, who are willing to perform this experiment? So we used the VR lab as our tool for that. And the main idea was that we should really be able to focus on the test from Durham, and there should no other objects or instruments or light conditions or sound conditions stand in the way. So therefore we made a setup in the middle of the lab, completely with combined with the lighting equipment. So when they performed the test, the light would be the same for every participant, no influence by daylight or no influence by any light coming from other rooms, just to see how do people respond to the new type of 3D information. What they took as a variable was the screen distance and the content they showed on the screen, and in total they had 50 participants in groups of 3 at the same time to test their new 3D viewing experience. We use a simple 3D projector with 3D goggles, and the only difference was between the already available equipment in every local store and what we showed there was a type of content. So it was a really new way of rendering, which was an algorithm developed by Durham. So that's 3 participants at the same time for 30 minutes a group, and they watched the movie and filled in some questionnaires. And in total 50 participants, or I guess it was 49, worked together with them. And they're now still working on the results from that, because they did the same 2 times already in the UK, and they're now evaluating the results and performing more tests, and I think even more things around Europe. So what we see now is that we don't have really results from them yet, and they're still evaluating it, and we hope to see the report and also the publication within a short time. The second TNA we had was a human-robot interaction at a total distance of 2,000 km over a 40G network, also including 4K low-latency live visualization. So the idea was that we would like to give the end user the ability to manipulate objects over distance, really feeling that they are manipulating it, but also seeing it. And the biggest challenge for us was to make the good combination between hardware, which makes it available, and also by reviewing what is the thing the people experience. Is it what we expected them to experience? So the goal was that we want to move objects in a remote location as if you are moving the objects in the same room. So the questions we had also from Siena, also from PSNC and from SurfNet and the University of Twente for groups was the question, what is an acceptable experience? So what is the right combination between a large bandwidth connection, the correct hardware, what may be even most important, a low latency, mainly due to the combination of different senses, like for example the visual feedback, but also the haptic feedback. And if there would be any interruption between those two senses, we had the idea that it really would negatively influence the experience. So as the input for the end user, we used haptic master devices to get a real haptic feedback on moving objects. And that's the thing the University of Twente focused on. PSNC and SurfNet focused on using a 4K live stream between the two locations, and also both in a 2D version and in 3D version, and compressed and uncompressed, to see what is the most ideal situation and what is the needed bandwidth and how low should the latency be to perform most optimum. So the approach was that the synchronization between those two, the visual and the haptic feedback, was crucial. Any delay would be directly noticeable for the end user, but also for the task they had to perform. So we should come up with some kind of a task which is quite depending on haptic feedback. You should really feel what you were doing, but it should also be supported by some kind of visual feedback. So you really need the combination of haptic and visual to make it, well, the best experience. We performed this setup at the Terina Network Conference. It was in Maastricht in June 2013 in Netherlands. It was set up for 4 days with hundreds of participants who could open use the setup as they want. So there was no obligation of using it. It was really asking the user from, well, try it out and, well, help us with this test. So the things we would like to demonstrate in that technology or in that setup were the following technologies. Well, for the video, we had the 4K 3D at 60 frames per second, and I think Maggie will explain more about that in their seminar. Also the light paths between Potsdam, which was the first location, Maastricht, the second location, how those things worked was more to SurfNet, Siena and Potsdam. And we focused really at the two haptic masters and the task they had to perform. How should we align that? So the University of Twente focused on integrating those two haptic masters, which are in effect large-scale haptic interaction devices, which could perform quite some kind of a force to the end user in 3 dimensions. So there's no rotation, only X, Y, and Z adjustments. And to see if people would like that feedback in combination with 2D or with 3D video, and what kind of quality. Is 1080p enough, or do we need 4K? So the whole configuration was divided into 4 parties and 4 types of technology. And then we had to come up with what kind of feeling and what kind of experience do we want to give to the end user. What is really a real-time experience? What kind of task is, well, useful for some kind of haptic feedback? So it should be visual attractive, but it should also something which people understood, and it shouldn't really distract from technology. It should just be a task which should also be performed without technology at a normal location, so no distance location. So we come up with the game of the Leaning Tower of Pisa, as we call it, but then remotely. So people had to stack items on an unstable tower using the haptic master arm, so the robot arm, with a distance of 2,000 kilometers. So the haptic interaction part, which was about feeling and touching and manipulating those 3-dimensional objects, using 2 identical haptic master arms. And what we did, we was only simulating the force and the weight. So people had to build blocks on the leaning tower, and those blocks had different weights, and they really felt how much weight they have to lift and how it feel, or how it should stay on the leaning tower. We only had 3 degrees of freedom, so there was no rotation included in this one. We had 2,000 kilometer optical paths, mainly provided by SurfNet, which was dedicated light path between Potsdam and Maastricht. So we had quite a good connection And well, the idea was what is now real latency we experience and how much data can we use in this kind of setup without disturbing the user or distracting him with his task manipulating an object. Next up was the setup of Potsdam. What we had there were the cameras, of course, which will Mathieu explain in his seminar, and our robot arm and the haptic master, and the leaning tower. And this was the view, more or less, what the people had in Maastricht. There was some kind of camera view, so they could see the haptic master, the copy of it, which was in Potsdam, and the building blocks they had to put on leaning tower, and they could really feel that arm at the location in Maastricht. We had a setup there with in the middle a haptic master and the user. At his left side an holograph boot which showed 3D visualization at full HD quality of that setup, but also the 4K screen, projection screen from Potsdam in 3D, and two 4K screens, one with confirmation and one just raw data, just to see what is the best experience for the end user. And the next slide is how Maastricht looked, and there was, as a game element, performing a task with a certain amount of time to do it as fast as possible. And people had a choice to what screen they would like to use. So people could choose to use the 3D 4K screen, but also the normal Full HD screen, or the 3D Full HD, or the other 4K screens, just to see what is their best support in performing the task. What you see here is that the haptic master in Maastricht was the same one as in Potsdam, so they really had a good comparison in what is happening in Potsdam compared to what is happening in Maastricht. And those were the two 4K screens we used, one with confirmation, other just raw data. Well, the result was that the latency of the whole network was approximately 60 milliseconds for the visual feedback, which was 50 milliseconds for the video to get it over the network. And the network itself had 10 milliseconds of delay or latency. And haptic masters performed, or we couldn't really measure it at the millisecond accurate, but it was below 20 milliseconds of haptic latency, and it wasn't really feelable for the end user. They could just touch it and they had the idea that it was a one-to-one interaction with the device 2,000 kilometers away. In total, 660 participants used the setup, and none of them really experienced any loss of quality from the video or from the normal feedback or haptic feedback. And most people looked at the large 4K 3D screen. That was the most impressive one and also helped best with performing the task, because the depth participation was a real added value to this experiment. So this TNA was a good combination between TNA from University of Twente and Jena and the TNA between Potsdam and SurfNet. And together we all combined our forces into performing or setting up such a kind of demonstration which worked for 4 days in a row without real big problems. So I think it was one quite interesting demonstration to see how we can use all kinds of equipment from different companies, different parties, and perform a very good task, a very good test to end users.
I well understood the setup and the objective. I less understood on the first TNA what was the result and what you demonstrated respect to the 3D TV. What are the troubles and what was the conclusion of this experiment? And on the second project, is quite the same question indeed I would like to ask, because you noted clear conclusions that people did not felt disturbance about visual disturbance and latency between all the system, but you did not measure when it was the system was coming. Did you try to change the latency, for example, to see when people were experiencing that it was a problem or not? Because you could change artificially the latency.
Your first question. What I experienced the setup, and of course for me as creating a setup for Durham University, It was more about creating the right environment that people or that participants weren't distracted by any external influences. The real results from the test are still processed by Durham. So what the people answered in the questionnaire and how it's compared to what people in the UK answered is for me still unclear. The only thing I know is that when we performed the TNA, the results were as clear as they expected it to be. So the setup of the TNA, the use of the equipment, was just the way they expected it to be, and a real good copy of how they did it in the UK. So I hope that I get the results of them very soon in some kind of fun paper or article or publication. And of course I will provide it to all Visionair members. Well, the second one is a good question about when is the delay too much and when is it really obstructing the end user. Well, we performed that test I think more than a year ago to test if there is really an issue, and at that moment we integrated artificial latency just to see when are people really disturbed by the latency. And there we saw that when we have more than approximately 120-150 milliseconds between the haptic and the visual feedback, that you get the real issues. And also between the real world and the first feedback people get, it should really be for video lower than, well, in my opinion, 100-150. But I must say that we didn't test that one during this experiment, because if we wanted to test them, we had to have more dedicated environment, more controlled environment, and we had to have participants really performing our tasks in the way we wanted to do. And it was more for us to see, is it possible to test these kind of equipment, the combination between all the four parties with their own hardware, and is it really able to do so? And I think now it's more optimizing on, okay, if we can do this one, and we have latency lower than 20 milliseconds, is it good enough for us? Well, at this moment it is. And finding out what the most optimum is I think, something we have to do in the future.